Hey, so today we're going to be learning about cross-sectional volumes. This may seem like a very difficult part of calculus, but trust me, it's not that bad. The first formula that we need to know is volume equals the integral of a to b area x dx. So this is if we were trying to find the volume using the x-axis. Now if we were told that it's perpendicular to the y-axis, let's just say the volume is going to be from C to D area y dy. Y-axis. Now that we know our two basic equations, let's look at some following figures and see if we can find the area in terms of some side, which we will call S. For example, for a square, if we know that this side here is S, we know the area is going to be S times S, or S squared. Next up, if we have an equilateral triangle, we know the area is going to be root 3 over 4 S squared. Next, if we have a semicircle, and we know that this is S, the area is going to be 1/2 pi times 1/2 S squared, or basically pi over 8 S squared. Finally, if we have an isosceles right triangle, and we know this is S, if the base is the hypotenuse, we know the area is going to equal 1/4 S squared. So now, let's look at our first practice problem. I'll read it out loud. The base of a solid in the region enclosed by the semicircle is y equals rad 25 minus x squared, and the x-axis. Cross sections are perpendicular to the x-axis are squares. So let's graph this first so we know that what we are looking at. It is a semicircle of rad 25 minus x squared, which will look something like this. Now it is enclosed between the x-axis and this equation, so the area will be that shaded in region. Now we also know that the cross sections are going to be squares, which means the area is going to be S squared. We know that S here is any value here, which is, funnily enough, rad 25 minus x squared. Now, going back to the original part, we are going to find that the equation that I stated before was the volume is going to be the integral from A to B of the area. We know our area is going to be S squared, and that S is equal to this. Now all that we have to find are the 2 points where the equation y equals rad 25 minus x squared and the x-axis meet. So we are told in the graph that it is at -5 and 5. Using all the information we have, we can now plug this in to our own integral. So we can see that v is going to be the integral from -5 to 5. And we know that the area is s squared. S is rad 25 minus x squared, which will all be squared dx. So here we have the area 25 minus x squared. We have the area. Now, what we are going to do from here is simplify. Because it is squared on the outside and we have a rad, we can just bring this down as the integral from -5 to 5 of 25 minus x squared dx. Now let's simplify a little more. When we take this integral, we are left with 25x minus 1/3 x to the third from -5 to 5. After plugging in, what we're going to get is 125 minus 125 over 3, all minus -125 plus 125 over 3, which is going to simplify to 500 over 3, which is our final answer. So now, let's go on to our next question. This question is going to be a calculator question. I'll first read it all out. The region in the first quadrant bounded by the graphs of f of x equals 1 plus sine 2x and g of x is equal to e to the x divided by 2 is the base of a solid. For this solid, the cross sections perpendicular to the x-axis are semicircles with the diameters extending from y equals f of x to y equals g of x. Find the volume of this solid. So, this is a calculator question, but I always recommend graphing it out first. Basically, what we have is in the first quadrant, y is equal to f of x and y is equal to g of x. Now, we see that the cross sections in this question are semicircles, which means our area is going to equal pi over 8 s squared. Now, we know that the top half from here to here is greater than from here, the bottom half. So what we are going to do is we are going to try to find the area in between these two things. What this means is we're going to have to take the larger one and subtract it from the smaller one. So the larger s from the smaller s. And then what we're going to have to do there is put it all into the area of this. So basically, what we're going to find is the volume is going to be equal to the integral from 0 to the point of intersection here, A, which we can find using our calculator, pi over 8, because the area is pi over 8 s squared, of 1 plus sine 2x minus e to the x divided by 2 squared dx. After finding the point of intersection and plugging into the calculator, our answer will be 0.078. I want to end this lesson by going over some of the most important things that we learned. First, I will remind us all that the most important thing is knowing the areas in terms of S. So for a square, the area is S squared. For an equilateral triangle, the area is equal to rad 3 over 4 S squared. For a semicircle, the area is equal to pi over 8 S squared. For an isosceles right triangle, the area is going to equal 1/4 S squared. By the way, this is when the hypotenuse is the base. For a rectangle, we are going to do the area is equal to S times how much, like n times its base. So if this is B, how many n times is B greater than an S? So S times n times S, which is basically S squared n. Secondly, I will remind us of the most important equation that we will need to know, which is V is equal to the integral of A to B of the area dx. And finally, I will always recommend graphing it out and just looking at it so you truly understand what the question is asking you. Thank you.